Settle in and let your breathing slow. The room is quiet and the world outside can wait. Tonight, you are stepping into a crime scene that has already stopped moving. No drama, no chase, just tape on the floor, a soft flashlight beam, and the patient work of noticing. Bloodstains, when you look at them like a sleepless scientist would, are not shocks. They are materials with simple habits. They fall, they spread, they dry, and they leave small, stubborn shapes behind. In the next hours, you will watch those shapes become gentle geometry, drops, smears, faint traces in tilted light, until the scene feels less like a story and more like quiet physics. The first thing you learn standing inside that taped boundary is how little action there is. Most of this job is stillness. You look, you write, you look again. You make a slow map with your eyes, then with your camera, then with your notebook. The only sound is paper shifting, a pen scratching, and the soft click of a flashlight changing angles. You might think forensics is about solving the whole mystery in one clever moment. That is the fairy tale. Here is the routine. You document what exists before your own presence changes it. Even the air you bring in on your clothes matters. Even your warmth matters. A crime scene is not frozen in time. It is simply unattended, still reacting, still drying, still settling. Blood shows up in this quiet work because it is both common and stubborn. It is a fluid that wants to move and a stain that refuses to leave. It is a clue that does not need electricity or a password or a witness who answers the phone. It sits there and behaves like blood, which means it behaves like physics. So you begin with gentleness, not because you are sentimental, but because you are careful. You do not chase drama. You protect details. You do not interpret first. You photograph first. You note where the stain is, what surface holds it, and what the edges look like. You are not reading minds tonight. You are reading matter. A small, quiet truth settles in quickly. What you call a crime scene is often just a room that has stopped being cleaned. Dust returns. Humidity shifts. Airflow drifts through vents. And blood, like any wet thing left alone, starts a slow transformation from moving liquid to fixed pattern. And once you stop seeing it as something shocking, you can start seeing blood the way a scientist does, like a material with habits. Blood is a complicated fluid, but it has a simple personality. Fresh, it is warm, glossy, and mobile. It behaves like a thick liquid that does not want to be one thing for long. It separates, it clots, it sticks. It carries cells and proteins, and it responds to air like a cut apple responds to oxygen, darkening, changing, settling into itself. When you meet it on a surface, you are meeting a moment that has already passed. The body is gone, or it has moved, or it is quiet now. The blood is what remains, a record of contact between a living system and an indifferent room. On smooth tile, the stain can sit proud and rounded like a bead that spread until it got tired. On unfinished wood, it sinks into pores like water into a sponge, making edges softer, darker, and harder to lift. On painted walls, it may cling to the paint film and dry like a thin shell. On fabric, it wicks along threads, crawling outward in little capillary paths, making the stain look larger than the original drop. That difference Tile versus wood versus cloth matters more than people expect. In television stories, blood is always the same bright red splash. In reality, blood is a negotiator. It bargains with the surface. It asks, are you smooth? Are you thirsty? Are you warm? Are you dusty? Then it responds accordingly. Color is another slow signal. Fresh blood can look bright, almost cheerful, in a way that feels inappropriate. Give it time and oxygen, and it deepens into darker reds and browns. That shift is chemistry doing what chemistry does. Iron and hemoglobin changing its state, the stain drying from the outside inward, the surface crust forming first, while the center stays wet a little longer. You can also watch the stain's texture change. Wet blood shines under a flashlight. Dry blood goes matte. Partially dried blood can look like it has a skin, slightly cracked at the edges, with a darker core beneath. If you have ever left paint on a brush too long, you understand the vibe. Humidity plays its own quiet game. In dry air, stains dry faster and can form sharper boundaries. In humid air, drying slows and stains can stay tacky longer, collecting dust or smearing if touched. Airflow matters too. A vent that blows steadily across a floor can change drying patterns, making one side crust sooner than the other. Time is the silent technician in the room. It takes every stain and runs the same program. Spread, soak, clot, dry, oxidize. Your job is not to rush it into a story. Your job is to notice the stage it is in and record it without adding your own fingerprints to the script. And when a drop finally leaves the body and meets the floor, it starts making shapes that feel random until you look a little closer. A single drop falling straight down is surprisingly polite. It hits, it spreads outward, and it often leaves a shape that is mostly round. Not a perfect circle, because nothing is perfect in a real room, but round like a tiny, messy coin. The edges can be smooth, or they can be slightly scalloped, depending on the surface and the energy of the impact. If the drop falls from higher up, it hits with more speed. That extra energy can make the stain larger, and it can also create little satellites, tiny specks flung outward from the main drop. They look like a faint constellation around a planet. They are not dramatic. They are just droplets doing what droplets do when they hit and rebound. If the drop hits at an angle, the stain stretches. Instead of round, it becomes an oval. And the oval can whisper direction. One end is often more rounded, and the other end can taper, sometimes with a small tail. It is not the stain pointing like an arrow on purpose. It is simply geometry, momentum meeting friction. You learn to look at the long axis of that oval and the way the tail leans. You learn that a shallow angle, like a low skimming drop, makes a longer stain. A steeper angle makes something closer to a circle. These are gentle truths, not mind reading, not psychic impressions, just shapes and angles. Edges tell their own quiet story too. On a smooth, sealed surface, the edge can be crisp. On rough concrete or textured paint, the edge breaks up, jagged and irregular, like a coastline seen from far above. That is the surface interrupting the spread, grabbing the fluid in tiny places, forcing it to dry in uneven borders. Sometimes you see spines, little projections at the edge of the stain. Sometimes you see separate droplets, satellites that landed nearby. Those small marks can hint that the drop hit with enough energy to splash, or they can hint at something else, like a drop landing on a surface already wet, or a drop striking another drop, making secondary scatter. And because you are a patient creature tonight, you do not jump to conclusions. You do not see one oval stain and announce a full narrative. You look for patterns. Do multiple stains share a direction? Do they cluster? Do they change size in a consistent way? Are they on a horizontal surface, a vertical surface, or both? Vertical surfaces behave differently. A drop that hits a wall can form a tear-shaped mark, and gravity may pull it downward into a drip. That drip length can tell you something about volume and drying, but it also tells you something about time. A slow drip means the blood stayed wet enough to move. A stain with no drip may have been smaller, or the surface may have absorbed it quickly, or the blood may have already begun to thicken. That thickening is one of blood's most important habits. Blood is designed to stop moving when it escapes its proper containers. It clots. It forms a gel. It makes a plug. That is survival. But on a floor, it becomes evidence. Clotted blood can create uneven stains with darker, thicker areas. It can leave texture that looks almost granular when it dries. You can also meet stains that look diluted, lighter in color, more watery at the edges. That can happen when blood mixes with another liquid, water from a sink, condensation, rain tracked inside, cleaning fluids, or even other body fluids. The stain's behavior changes when it is not just blood anymore. It becomes a mixture with new rules. The longer you stare at these shapes, the more you realize they are not random. They are the repeated signatures of gravity, surface tension, viscosity, and time, written in a language made of edges. If you follow those little shapes long enough, you'll eventually wonder about motion, because some stains don't look like drops at all. Drops are honest about falling. Smears are honest about contact. A smear is what happens when something wet touches something dry and then moves. It can be a hand against a wall. It can be a sleeve brushing a door frame. It can be a knee, a shoe, a shoulder, any surface of a body or object becoming a stamp, then dragging. The first quiet question with a smear is simple. Is it a transfer or is it a swipe? A transfer is when a bloody object touches a surface and leaves its pattern behind. A swipe is when a moving object travels through an existing wet stain, picking up blood and redistributing it. They can look similar at first glance, like two versions of the same messy signature, but their details differ. A transfer can preserve texture. If a bloody palm presses to painted drywall, you might see ridge patterns softened by the paint's texture. If a bloody shoe touches tile, you might see tread shapes. Sometimes it is clear. Sometimes it is just enough to suggest rubber, fabric, skin, something patterned. A swipe often has a beginning and an end. The beginning can be heavier, darker, and more saturated, where contact first occurred. Then the stain can lighten, feather, or streak as the moving surface runs out of liquid. The end may taper, with thin lines where the last moisture clung and stretched. It is not cinematic. It is simply depletion. Direction can hide in that depletion. The heavier part is often the start. The lighter, thinner part is often the finish. But you treat that often with respect, because surfaces complicate everything. A rough wall can scrape liquid off faster. A smooth surface can let it travel farther. And a clot can make a smear look interrupted, like a brushstroke with lumps. Layering matters in a quiet way. One mark can sit on top of another. If a smear crosses a dried stain, the overlap can show which came first. Dried stains can crack, and wet smears can fill those cracks. Or a later stain can sit glossy on top of an older matte layer. When you look closely, you are not seeing a single event. You are seeing a sequence. Sometimes, the movement you see is not the movement of the original incident at all. Sometimes, it is cleanup. A towel dragged across a floor can leave long, repetitive streaks. A mop can make arcs. A sponge can leave swirled patterns. And people, when they panic, do not clean like professionals. They miss corners. They wipe around objects. They leave faint residue where they thought they erased everything. Cleaning can also create its own strange signals. Dilution lines can form. A stain can look lighter in the center where scrubbing happened, but darker at the edges where liquid was pushed outward and left to dry. It is like pushing dust under a rug, except the rug is the laws of chemistry. Your flashlight becomes a gentle tool here, not to dramatize, to reveal texture. At a low angle, light skims the surface and makes raised, dried residue cast tiny shadows. It can make a smear look three-dimensional. It can make cleaning marks show up as dullness, or streaking, or changes in reflectivity. And through all this, you stay modest. You are not the hero of the room. You are a careful recorder. You do not force a story onto a smear. You let the smear be what it is, contact and motion, recorded in dried fluid. And speaking of seeing what's really there, sometimes the most important stains are the ones you can barely see at all. Not all blood looks red in every light. On a dark carpet, it can vanish. On brown wood, it can blend in like an old knot in the grain. On patterned fabric, it can hide inside the pattern as if it was always meant to be there. Your eyes are good, but they are not honest instruments. They get tired, they adapt, they miss things. So you learn to use light like a slow, patient question. You change the angle. You lower it close to the surface. You look for changes in texture, not just color. Dried blood can make a surface slightly stiff. It can change the sheen. It can create a faint crust that catches light differently than the clean area around it. Sometimes the search is nothing more than scanning. A careful sweep, inch by inch, with the beam tilted and the room kept dim. It is not dramatic. It is closer to looking for a lost earring on a carpet, except the earring is a darkened stain that might be 1 millimeter wide. There are chemical methods too, used when the situation calls for them. Some chemicals react with components of blood and produce a color change. Some can create a faint glow in the dark, a kind of cool luminescence that shows where blood might have been, even after cleaning. It sounds exciting, but the reality is quiet. You spray, you wait, you darken the room, and you observe. And you remember, always, that these tests are not magic truth. They can react with other substances, some plant materials, some cleaning agents, and some metals can create similar reactions. So the result is not a conclusion. It is a guide, a suggestion of where to look more closely, where to swab, where to document. That is a theme in real forensics. The dramatic moment is rare. The common moment is confirmation. You find something faint, you test it gently. You take notes, And you plan the next careful step. Even the act of photographing matters. You include a scale. You include context. You take wide shots, then mid shots, then close shots. You keep the camera square to the surface when you can to reduce distortion. You are building a quiet archive that someone else can read later, when the room itself is long gone. Because rooms do not stay the same. People walk through them. Doors open and close. Sun shifts across windows, and once you start collecting, you begin the most delicate part of the ritual. Taking a small piece of the scene without breaking its meaning. Once a stain is found, the next step isn't guessing. It's quietly collecting, so the story doesn't get ruined by fingerprints and chance. Collection is not glamorous. It is gloves and swabs and labels, repeated until it becomes almost meditative. You put on fresh gloves because skin cells are noisy. You use clean tools because the world is full of DNA, and it loves to travel. You package items in paper, not plastic, when moisture is a concern, because sealed plastic can trap humidity and encourage mold, and mold is a tiny vandal with a talent for destroying biology. If the stain is wet, you may collect it differently than if it is dry. Wet stains can be swabbed gently, but they also need to dry properly in controlled conditions. Dry stains can be swabbed with a moistened swab, careful and consistent, using a small amount of sterile water. The goal is not to scrub. The goal is to lift a sample without smearing the rest. Sometimes you cut a small section of fabric, sometimes you take the whole item, folded carefully so stained areas do not touch clean areas. Sometimes you collect a control sample, a clean swab of the unstained area nearby, so the lab can compare background material. Again, quiet repetition. You do it the same way because the same way is defensible. Every item gets a label, where it came from, when it was collected, who collected it. A short description that is plain and practical. This is not poetry. This is bookkeeping for reality. And then there is chain of custody, the least romantic phrase in all of human curiosity. It is simply the record of who had the evidence, when they had it, and what they did with it. A bedtime story of ownership, told in forms and signatures, because the science can be perfect and still fail in court if the evidence cannot be accounted for like a careful package in the mail. Contamination is the enemy, but it is not an evil genius. It is ordinary life. A sneeze, a hair drifting down, a pen that touched a glove, a swab set down for 1 second on the wrong surface. The procedures exist because humans are messy animals who like to make mistakes. So you slow down. You change gloves often. You use fresh swabs. You seal bags properly. You document before you touch. You document after you touch. It is repetitive on purpose, like a ritual designed by someone who does not trust your memory. And that someone is correct, because later, in the lab, the stain will stop being a stain. It will become a sample number, a barcode, a small tube, and the only thing connecting that tube to this quiet room is your documentation. And after the careful collecting comes the quieter world behind the scenes, where stains turn into notes, and notes turn into lab work. In the lab, you stop being a person with a flashlight and become a person with a bench, a sink, a stack of forms, and the soft hum of refrigeration. The air smells faintly of disinfectant and old cardboard. Everything is clean in the way that says, someone has tried very hard to keep biology from doing what biology loves to do, Your evidence arrives like quiet mail, a sealed bag, a label, a case number that means nothing to the molecules inside. You sign it in because the chain of custody does not stop at the lab door. It only changes hands. And here is the first unromantic truth. Most tests start by asking a boring question. Not who did it, not why. Just, what is this stain likely to be? You open a file and you see the same cautious words repeated like a lullaby for anxious people. Presumptive test, confirmatory test, suitable for DNA, unsuitable for DNA, limited sample, degraded. You do not get certainty as a default. You get probability with paperwork. The first kind of test you meet is the kind that behaves like a nosy neighbor. It is not a courtroom statement. It is a hint. It is a presumptive test, meaning it can suggest blood is present, but it can also be fooled. Blood has a convenient weakness. It is good at helping chemical reactions happen. That is the job of hemoglobin, the oxygen carrier in red blood cells. The iron inside it makes certain reactions run faster, like a tiny catalytic engine. So you add a reagent, a simple chemical mixture, and you watch for a color change. If it turns, you get a quiet little thrill that you immediately suppress, because this is how mistakes are born. Some cleaning agents can also make it turn. Certain plant materials can make it turn. Even some metals can make it turn. Congratulations, you have detected the possibility of blood, or the possibility of someone cleaning their bathroom aggressively. A classic example is the Kastle-Meyer test, pronounced like Castle and Meyer like Meyer. It uses phenolphthalein, a chemical that shifts color with oxidation. In plain human terms, you touch the stain with a swab, you add the chemicals, and if hemoglobin is around to speed things up, the swab blushes pink. Not instantly pink in every case. Sometimes it is slow. Sometimes it is faint. Sometimes it is a dramatic bubblegum color that makes you suspicious because it looks too eager. You learn to time it. Reactions that happen immediately are more suggestive. Reactions that happen late are more questionable. And you write it down in careful language, because your job is not to be impressed by chemistry. Your job is to record it. There are other presumptive tests too. Some are based on luminol, pronounced lu-mi-nol, or similar chemicals. They can glow in darkness when they react with blood, producing a pale, cold light. It is beautiful in a way that feels unfair. The room goes dim, and suddenly faint patterns shimmer like ghost handwriting. But luminol has its own personality. It is sensitive, and it is indiscriminate. It can react with bleach. It can react with certain metals. It can also dilute and slightly damage DNA if used heavily, because you are spraying chemicals on biological material and hoping it remains cooperative. In the lab, you treat presumptive results like a map, not a verdict. They tell you where to look closer and what to prioritize. They do not tell you a story. After presumptive comes confirmatory. This is where you try to answer more firmly whether the stain is actually blood. Sometimes the lab uses microscopic examination. Sometimes they use crystal tests, older methods that form distinctive crystals when blood is present, like tiny geometric proof. These can be finicky, and not every lab uses them routinely now, but the principle is soothingly old-fashioned. Chemistry and patience. A slide, a stain, a slow look through glass. Then there is a different question, equally annoying and equally necessary. Is it human blood? Because the world is full of animals, and animals are full of blood. And some scenes include pets, pests, or meat from a kitchen. Your stain might be human, or it might be a cut finger on top of a steak juice spill. Reality enjoys that kind of overlap. To sort that out, labs can use immunological tests. That means antibodies, the same kind of molecular recognition tools your immune system uses. Antibodies bind to specific proteins. Human blood has proteins that can be targeted, and other species differ enough to be distinguished. These tests are not magic either. They can cross-react with closely related species sometimes. Primates can be awkward for obvious evolutionary reasons, but for many practical scenarios, they help separate human from non-human. You watch the lab become a place of careful narrowing, not dramatic leaps, just steady elimination. It is like walking down a hallway, closing doors behind you until only one or two are left open. And then comes the part people whisper about, DNA. The public treats DNA like a glowing barcode of identity. In reality, it is a fragile molecule, folded up inside cells, vulnerable to heat, moisture, sunlight, microbes, and time. It is not a divine signature. It is an instruction manual that tears easily. Blood can contain DNA, but the main cells in blood, red blood cells, do not have nuclei. They do not carry nuclear DNA at all. They are basically hemoglobin delivery sacs. That surprises people. So when you get nuclear DNA from blood, you usually get it from white blood cells. Those are the immune cells, the ones with nuclei, drifting through the bloodstream in smaller numbers. This means a clean-looking red stain can still yield DNA because white blood cells are mixed in. But it also means some stains yield less than you want, especially if they are old, exposed, or cleaned. If you are working with very little material, you begin with extraction. You break open the cells and you separate DNA from proteins and other debris. This can be done with chemicals and spin columns or magnetic beads, depending on the lab's method. It sounds simple when summarized. In practice, it is a careful ritual with timed steps and controlled conditions. Tube after tube, pipette tips changed constantly. Controls included to catch contamination, because if you introduce your own DNA into the sample, you have created a problem that can haunt the case for years. Once extracted, DNA is quantified. That means measured, not just. Do we have some? But how much? And what kind? Some kits can estimate how degraded it is. Some can estimate whether inhibitors are present, chemicals that interfere with amplification later. Inhibitors are the quiet enemies, dyes from fabric, tannins from wood, detergents and bleach residues, soil compounds. The world is full of substances that hate your polymerase enzyme, and polymerase is the little machine you rely on to copy DNA. Polymerase chain reaction is usually shortened to PCR, but in your sleepy lab world, you can think of it as a molecular photocopier. It takes a targeted region of DNA and makes millions of copies so you have enough signal to detect and compare. The lab typically focuses on short tandem repeats, often called STRs. These are regions in the genome where a small pattern repeats, like a word stutter. Different people have different repeat counts at these locations, and the combination across several loci becomes a profile that is statistically powerful. You do not need the whole genome. You just need enough of these repeating markers to make a match unlikely by chance. But degraded samples complicate things. If DNA is broken into smaller fragments, longer regions may not amplify well. That is why forensic kits often target shorter fragments, because shorter survives better. Sometimes you get a full profile, crisp and complete, like a clean set of piano keys. Sometimes you get a partial profile, missing notes. Sometimes you get a mixture, meaning more than one person contributed DNA to the same sample. Mixtures are common. Life is contact. People touch objects. People bleed on things already touched. People share spaces. So you end up with overlapping signals, like two conversations in one room. Interpreting mixtures requires caution and statistics. You do not just eyeball it and decide. Labs use software and validated methods, and even then, they often use careful language. Consistent with, cannot exclude, likely contributor. Limited support. This is where the lab's personality differs from television. Television wants bold declarations. The lab wants defensible sentences. And while all this is happening, you remember something uncomfortable. DNA is not the same as time. DNA can tell you whose biological material is present. It usually cannot tell you when it got there. A smear on a doorknob might contain a person's DNA because they lived there last week. It might have nothing to do with a crime. Biology is persistent, and your interpretation must be modest. So the lab report becomes a careful object. It is a translation of molecules into human language, with uncertainty included on purpose. While you are still in this lab world, you also see how blood testing has layers beyond identity. There are questions about species, about whether a stain is menstrual blood versus peripheral blood, and about whether chemical patterns suggest certain events. These are specialized tests, not always used, but they exist. Sometimes the work is not even about identifying a person. Sometimes it is about excluding a possibility. Sometimes it is about showing that a stain thought to be blood is actually paint, or rust, or spilled wine, which is a suspect in more cases than it will ever admit. And this is the quiet charm of forensic science. Most of it is telling you what something is not. Now and then, you also meet the older techniques, the ones that feel like they belong in a wooden cabinet. Blood typing, for example. Before modern DNA profiling, investigators used ABO blood groups and enzyme markers. It could narrow down a population, but not pinpoint an individual. It still has uses in certain contexts. But in most modern labs, it is a supporting actor. DNA became the star, and stars have egos. Even so, you keep one thought pinned to the corkboard in your mind. Every test consumes sample. Every swab is a choice. Every chemical application changes what remains. So you proceed like someone handling the last pages of a rare book, because sometimes you are. When the lab work is done, results go back to the case file, and the case file goes back to people who will try to stitch it into a narrative. You do not control that narrative. You only control the quality of the measurements. And just when you start to feel like everything important is happening under fluorescent lights, you remember something. Blood is only one kind of quiet witness. Scenes shed more than fluids. They shed fibers, Hairs, flakes of skin, little crumbs of the world that travel without permission. They collect in corners and cling to fabric like shy passengers. And if you are patient enough, you start to see those passengers everywhere. A fiber is a tiny thing, and it behaves like a tiny thing. It sticks because of static. It hides because it is the same color as the carpet. It transfers because two people brushed past each other in a hallway with bad lighting and worse timing. Fibers come from clothing, upholstery, carpets, blankets, car seats. They can be natural, like cotton and wool. They can be synthetic, like polyester and nylon. They can be blends designed to survive washing machines and human habits. Under a microscope, a fiber becomes a landscape. You can see its thickness, its cross-sectional shape, its surface texture. Some synthetic fibers have very consistent shapes, engineered like mass-produced pasta. Some natural fibers show twists, scales, irregularities. Color can be compared, not just with your eyes, but with instruments that measure how a fiber absorbs and reflects light. Dyes have signatures. Two fibers that look similar in a dim room can differ under proper analysis. But the conclusion language stays humble. Fibers are class evidence more often than individual evidence. That means you can often say, a fiber is consistent with a source. Not that it came from one specific sweater in the history of sweaters. It is still useful because consistent with can link environments. It can support a timeline. It can show contact that someone denies. And contact is a theme you keep meeting. The world is not cleanly separated. It is a constant exchange of small materials, a slow trading of dust. Hair is another traveler. People like to imagine hair as an instant identifier. In reality, hair is both informative and frustrating. A hair can tell you whether it is human or animal fairly reliably with microscopy. It can tell you whether it came from the head or another body area. Sometimes, based on shape and characteristics, it can show signs of treatment, like dye, bleach, or heat damage. It can show whether it was cut or whether it fell naturally. A naturally shed hair often has a root with a particular shape, a club-like bulb. A forcibly removed hair may have tissue attached, a different look at the root, but hair without a root often has very little nuclear DNA. It is mostly keratin, a tough protein structure. Like biological plastic, you might be able to get mitochondrial DNA from it, which is inherited maternally and less individualizing than nuclear DNA, but it can still provide investigative information. Mitochondrial DNA is like a family surname shared down a maternal line, useful for exclusion, sometimes for inclusion, but not a fingerprint. So hair analysis has evolved. Older practices of making strong individual claims from hair microscopy alone have been criticized because the science does not support that level of certainty. Modern practice emphasizes limits and, where possible, uses DNA testing to strengthen or clarify. Again, the lab prefers careful truth over satisfying answers. Then you look down and you see the floor, the great collector of human motion. Footprints can appear in obvious ways, like muddy tracks across tile, but they can also appear as dusty absences, where a shoe stepped and removed dust, leaving a clean shape in a dirty field. Sometimes the print is made of blood, a transfer pattern from a shoe sole. Sometimes it is made of dirt. Sometimes it is made of fine powder that only shows at the right angle. You photograph them with a scale because sizes matter. You also note orientation, because direction matters. And if the print is three-dimensional, like in soft soil, you can cast it with dental stone, a material that flows in and sets hard, preserving the impression. Shoe soles are patterns designed for grip. They are also patterns designed to be compared. A tread can be class evidence, a brand and model type, but it can also develop individual characteristics. Wear patterns, nicks, cuts, embedded debris, those can make one shoe distinct from another. The way a well-used key becomes uniquely scratched. Still, conclusions must be cautious and methodical. Comparing impressions requires training and documentation. The world is full of similar shoes, and the human brain is too eager to see matches. Dust and dirt are quieter still, but they act like a travel diary. Soil is not just brown. It contains minerals, organic matter, microbes, plant fragments. Different locations have different compositions. If you pick up soil on a shoe, you pick up a mixture of geology and biology. In some cases, soil analysis can help link a person or object to a location, especially when combined with other evidence. It is not always definitive, but it is another thread. Even pollen can matter. Pollen grains are tiny and distinctive, and they travel on clothing and hair. They can indicate season, location, contact with certain plants. Palynology, the study of pollen, has been used in forensic contexts. It is niche, but it is real. The scene is a library of particles, and you are learning to read its dust jacket. All of these soft clues have something in common. They are shaped by time. Time changes blood. It changes fibers. It changes the persistence of prints. It changes the behavior of insects. And insects have opinions about unattended rooms. A scene does not sit still after an event. It continues to breathe with the building. Heat cycles on and off. Humidity rises and falls. Sunlight shifts across floors like a slow spotlight that fades what it touches. Blood drying is one of the most obvious clocks, but it is not a precise one. Drying depends on volume, surface, airflow, temperature, and humidity. A thin smear can dry quickly. A pooled stain can stay wet beneath a crust for a long time, like mud that looks dry until you step on it. As blood dries, it can crack. It can flake. It can soak deeper into porous surfaces. On fabric, it can bind strongly because proteins cling to fibers. On wood, it can become part of the grain. Oxidation continues. The color shifts. The edges may darken. The surface becomes more matte. Under certain conditions, microbial activity can begin to alter it too, because microbes are always present, waiting for free nutrients. Heat speeds up many processes. A warm room can dry stains faster. It can also accelerate decomposition of biological material. Cold slows things down. Refrigeration and freezing can preserve samples, but freeze-thaw cycles can damage cells and complicate analysis. Moisture is a double-edged presence. It can keep stains wet longer, which may allow smearing and transfer. It can also encourage mold growth on collected items if they are packaged improperly. Mold is not just ugly, it is destructive. It can digest biological material and complicate DNA extraction. It can also spread, turning one item into a contamination risk for others. Sunlight is another slow vandal. Ultraviolet light can break down DNA over time. It can fade dyes and fibers. It can change the appearance of stains. A scene exposed to direct sun for days is not the same scene it was at night. And then there are animals. Pets wander. Cats step in things and leave prints in places you will discover later. With a tired sigh, insects arrive, especially flies, drawn to biological fluids. They can create artifacts that resemble blood spatter because flies regurgitate and defecate small spots that can look like tiny stains. Yes, reality includes the phrase fly speck. It is exactly what it sounds like. And it has confused investigations. Because the universe enjoys practical jokes. Insects can also move material. They can track tiny amounts of blood. They can disturb soft traces. In some cases, their presence can even help estimate time since death in forensic entomology. But that is its own deep, crawling field of study. Here, you simply remember that a scene is an ecosystem, even indoors. It has airflow, light, temperature, humidity, microbes, insects. It is not a static photograph. It is a living process, even when the people are gone. And this is why investigators race the environment more than they race a villain. The clock is not always a dramatic countdown. It is a slow erosion. A footprint in dust can vanish with one careless step. A faint smear can be wiped by a sleeve. A wet stain can be altered by a heater turning on. Even the act of opening windows can change airflow and drying patterns. So, documentation becomes your anchor. Photographs freeze appearance. Notes freeze context. Measurements freeze geometry. Because the physical scene will not politely remain unchanged for you. When you return to the written world, you see how all these pieces become a careful narrative, not in a novel sense, but in a structured sense, a timeline made from materials doing what materials do. Blood drop shapes suggest direction and angle. Smears suggest contact and movement. Hidden stains suggest cleaning attempts or low visibility. Lab results suggest what a stain likely is, and sometimes whose biology is present. Fibers suggest contact. Hair suggests species, and sometimes more. Footprints suggest presence and direction. Dust suggests pathways. But you never forget the quiet rule: correlation is not confession. Evidence can be consistent with a scenario without proving intent. That is why good forensic conclusions are modest. When an analyst writes a report, they use careful phrasing. They avoid absolute statements, unless the science truly supports them. They state what methods were used. They state limitations. They note when a sample was too small, too degraded, too mixed. In court, if it goes there, those words matter. The difference between cannot exclude and did originate is the difference between a cautious scientist and a storyteller. And you, tonight, are staying with the scientist. Because a scene is not solved by one stain. It is understood by patterns that agree with each other. When multiple independent clues point in the same direction, confidence grows. When they conflict, you do not panic. You reconsider. You look for alternative explanations. You check for contamination. You verify documentation. You remember that humans are messy and rooms are complicated. Sometimes the most important outcome is recognizing what evidence cannot tell you. A bloodstain might show movement, but not motive. A DNA profile might show presence, but not time. A fiber might show contact, but not consent. And yet, even with all those limits, the work matters, because matter does not lie in the way people lie. It only behaves. It only follows rules, indifferent and consistent. That indifference is almost comforting if you are the kind of person who finds comfort in gravity doing what gravity does. You stand at the edge of this whole process and you see it as a loop. Seeing becomes documentation. Documentation becomes samples. Samples become lab results. Lab results become cautious statements. Cautious statements become part of a bigger timeline. The timeline becomes a case file, and the case file becomes a human attempt to make meaning. And while that meaning is being assembled, time keeps moving. Stains darken, rooms air out, dust resettles. The world erases itself with gentle persistence, which is why the best forensic work is patient, repetitive, and quietly stubborn. A refusal to let small patterns vanish unnoticed, even as the environment tries its best to smooth everything back into ordinary life. And if you zoom out just a little more, you start noticing that time itself leaves fingerprints, because scenes do not stay still. A stain that looked crisp at midnight can look soft by morning, not because it changed its mind, but because water in the air kept negotiating with it. Moisture drifts in, then out, like a slow tide you do not notice until it is gone. On porous surfaces, that tide pulls pigment and proteins deeper, turning a surface mark into a deeper set memory. You learn to respect the way a building breathes. Heating systems kick on, and warm air rises. Cooling systems cycle, and cold air sinks, leaving faint currents that rearrange dust like lazy weather. Even a closed room has movement. It just moves like a sleeping animal. This is why time is such a frustrating witness. It shows up everywhere, but it never signs its name. A drying stain is not a stopwatch. It is a set of conditions pretending to be a timestamp. Change the airflow, and you change the whole performance. Think about a pooled stain, thick enough to look almost still. The top dries first, forming a skin. Under that skin, liquid can remain for a long while, protected like soup under a cooling film. Touch it too soon, and you break the crust. Congratulations! You have just created a new pattern. And that is the recurring irony. The scene is fragile, but the universe is not. Everything around your evidence wants to push it, smear it, fade it, digest it, or carry it away. Your job is to show up in the middle of that quiet sabotage and record what has not vanished yet. Sometimes the sabotage is physical. A ceiling fan running all night can dry one edge faster than the other. A window left cracked can bring in dust, pollen, and damp air from outside. A radiator near the wall can bake stains into place, hard and brittle, as if the room tried to preserve them. Sometimes the sabotage is biological. Bacteria are always present, even in clean homes. They do not care about the story. They care about calories. Blood, sweat, and tissue residues are a banquet, and microbes do not need an invitation. Over time, they can change odor, texture, and the chemical friendliness of a sample. Then there are fungi, the slow, fuzzy opportunists. If evidence is packaged damp, mold can start a tiny empire inside a bag. It spreads across fabric, leaving spots and a musty smell that clings to paper and gloves. Mold can also bring chemicals that interfere with later testing. Because of course it can. Nature does not just ruin things, it ruins them in complicated ways. And in the background, sunlight keeps doing what sunlight does. It bleaches and breaks molecules. Not all light is equal here. Ultraviolet light is the part that quietly snaps bonds in dyes and in deoxyribonucleic acid, like a bored child tearing paper. It does not erase instantly. It just weakens evidence until the lab has to work harder and speak more cautiously. You might imagine investigators racing a person. In practice, they often race a room. A room is a machine for turning sharp events into soft traces. The longer the delay, the more those traces become ambiguous, not gone, just harder to interpret without wishful thinking. Even insects can become part of that machine. Flies arrive quickly when there is nutrient-rich moisture. They feed, they land, and they leave behind tiny specks that can look like small stains. Those specks can appear in clusters on walls, ceilings, and near light sources. It is not dramatic. It is just the biology of opportunists. And yes, an analyst may have to decide whether a dot is blood spatter or fly artifact, because reality insists on being annoying. Pets are their own category of chaos. A dog will walk across a floor with the calm confidence of a creature who has never had to testify. A cat will jump onto the one surface you hoped was untouched. Hair sheds, paws track dust, and a tail can sweep a coffee table like a feather duster with bad intentions. None of it is malicious, but none of it is helpful. So the clock keeps moving and the scene keeps changing. That is why documentation is so obsessive. You do not photograph because you like photographs. You photograph because the scene you return to tomorrow is not the scene you met tonight. And even within that documentation, time sneaks in. You note whether a stain looks glossy or matte. You note whether edges are wet enough to smear. You note whether there is cracking, flaking, or a dried crust. You note the temperature of the room, the humidity if you can, the windows, the fans, the heating. You are not just describing blood, you are describing the environment that shaped it. You also learn a quiet kind of humility about estimating time. People ask, how long ago did this happen? They want a clean answer, as if the universe runs on appointment times. In reality, you can sometimes say things like, this stain appears recently deposited, or appears dry, or appears aged, but you do not pretend it is precise. Two similar stains can dry differently in the same room if one landed on cotton and the other on sealed tile. And then there is the problem of disturbance. A stain can be stepped in. A smear can be partially wiped. A pooled area can be diluted by a spilled drink or water from a leaking pipe. A scene might even be staged, not with cinematic genius, but with clumsy human panic. Someone tries to clean, misses a spot, then cleans again, leaving layered arcs of effort. Layering is where time becomes visible again. A later wipe can leave streaks over an older dried stain. A newer drop can sit on top of an old crust like a second coat of paint. Sometimes you can see that difference in sheen under angled light. Sometimes you can see it in cracks. Older layers crack and newer layers fill them, like grout. If the stain is thick, It can even trap debris. Dust settles into wet blood, then dries in place, leaving a gritty texture. Fibers land, stick, and become part of the stain's surface. You end up with a microscopic timeline. Dust on top of blood, blood on top of paint, paint on top of older dust. The world stacks itself in layers, and you are trying to read the order without making it up. There is also the quiet chemistry of aging. Hemoglobin changes its form as it oxidizes. The color deepens, then browns, sometimes with a faint orange edge. Other components break down too. Proteins denature, meaning they lose their folded shapes, like a sweater shrinking in hot water. That matters because some tests rely on protein recognition, and aging can make recognition harder. In older stains, you can get something else: brittleness. Dry blood can flake, especially on smooth surfaces. A flake is easy to lose, easy to transfer, easy to vacuum up by accident. On fabric, dried areas can stiffen fibers, creating a patch that feels slightly crunchy, even if the color is subtle. And if water gets involved later, you get reactivation. Dried blood can partially dissolve and move again, especially if it was not fully bound into a porous surface. That can create halos, or rings, or blurred edges that look like they were always that way. But they were not. They are the result of the room continuing to do chemistry after the fact. You see why analysts like controlled experiments? Drop blood from a known height onto a known surface in known humidity, and you can learn a lot. But scenes are not controlled. Scenes are messy collections of unknowns. So your conclusions, stay careful, even when your eyes want to be confident. And this carefulness carries into the next step, turning all these observations into something a human system can use. Because evidence is not useful if it stays as a feeling in your chest. It needs to become diagrams, measurements, and language that does not get swept away by emotion. So, you return to the case file, where time becomes a different kind of layer. A timeline is built not from one clue, but from many small clocks: drying, transfer, disturbance, environmental change. Each clock is imperfect. Together, they can still point in a direction, like a handful of tired people agreeing on which way the wind is blowing. And before you ever reach a courtroom, there is a quieter and more common destination: the report. The report is where the scene becomes calm sentences. It is where the chaos becomes a list. You describe stains by location, size, and appearance. You describe the surface because the surface always has an opinion. You describe collection methods, packaging, and any tests performed. You attach photographs with scales and reference points. You include diagrams that look boring, which is exactly what you want. Boring diagrams do not exaggerate. The report also includes something people forget: what you did not find. Negative results matter. A presumptive test that did not react matters. An area searched with no visible staining matters. The absence of expected transfer can matter, depending on context. Science is not just finding, it is also ruling out. And you learn to write like a person who expects to be questioned later, because you will be. Your words are not private thoughts, they are tools that other people will handle. So you avoid poetic language. You do not say, "There was a lot of blood." You say, "There was an apparent blood stain, approximately this size, with this distribution, in this location. It can feel cold, but it is actually a form of respect. The scene is emotional for humans. Your job is to keep the measurements clean enough that emotion cannot bend them. Still, even clean language can be misunderstood. This is where the phrase consistent with becomes important. It means this pattern fits a certain explanation, but it does not exclude others automatically. A directional stain may be consistent with movement in that direction, but it could also be consistent with a different motion, producing a similar shape on that surface. Under those conditions, you leave room for reality to be complicated. Because reality is always complicated. Even bloodstain pattern analysis, the part people think is all about geometry, has limits. It can be useful for reconstruction, but it can also be overclaimed. A conscientious analyst knows the difference between what is supported and what is speculation. They use experiments, validated methods, and careful documentation. They resist the temptation to become a storyteller. And this is where you meet an uncomfortable historical footnote. Forensic disciplines have grown over time, and not all grew with the same scientific rigor at first. Some methods were adopted before they were thoroughly tested. Some testimony in the past was more confident than the data allowed. In recent decades, there has been a push to strengthen standards, improve training, and quantify uncertainty. So in a modern, careful setting, your report is full of modesty. It reads like someone trying very hard not to lie by accident. It may frustrate people who want certainty, but it is the only honest way to do it. The universe does not owe you a clean answer. Now, while all of this blood and dust and time is being organized into a file, there is a quieter truth waiting underneath. Forensics is not a single science. It is a crowded hallway of sciences: chemistry, biology, physics, statistics, microscopy, materials science. A crime scene is just a place where those sciences collided with human behavior, which means you can follow a thread away from blood entirely and still stay inside the same calm discipline. Because other substances also keep secrets, and they keep them in their own boring ways. Consider a stain that is not blood at all. It could be a reddish-brown mark on a sink. Rust looks dramatic when it wants to. So does spilled wine, certain cosmetics, and some cleaning products that oxidize and darken. The human brain is wired to see blood first. Because blood is emotionally loud, chemistry is emotionally silent. So you test and you confirm, and sometimes you disappoint someone by saying, "This is not blood, it is iron oxide. It is paint. It is a food stain, probably from a sauce with paprika." And yes, that is a real thing that happens. Congratulations. The stain that looked like tragedy is actually dinner. But even that disappointment is useful because it narrows the story back toward reality. It reduces the number of imaginary scenarios people can build, and reducing imaginary scenarios is one of the gentlest forms of order humans can make. You also meet the way evidence becomes a timeline through paperwork. Chain of custody forms are dull, and that dullness is protective. Each signature is a small anchor against chaos. If an item leaves the scene, it enters a system that must keep it identifiable and unaltered. In a perfect world, that system is seamless. In the real world, it is run by tired humans. So, the forms matter. A tiny mistake on a label can cause enormous trouble later. Wrong date, wrong location, wrong initials. Not because the molecules changed, but because trust changed. Science, in a legal context, is not only about results, it is also about process, and process is made of boring details. And then, after all that slow work, there is a moment that feels almost anticlimactic. A case file is closed, or passed along, or archived. The physical evidence goes into storage. The scene itself returns to being a room. Someone cleans, someone repaints, someone moves furniture. Life continues with its insensitive normality. The building keeps breathing, dust keeps falling, the environment keeps erasing, and people keep living inside the erased space. That is not a moral lesson. It is just what happens when biology occupies architecture. Rooms are temporary containers. So are bodies. Everything is on loan. And that brings you back to the simplest, strangest comfort in all of this. The evidence you study is not a supernatural message. It is matter behaving consistently. Fluids spread, fibers cling, dust settles, chemicals react, time degrades. When you look at it that way, the horror drains out, and the mechanics remain. Not because the human story is unimportant, but because your role is to keep your hands steady, to keep the language clean, to keep the conclusions modest. And now, with the file thick with photographs and careful phrasing, you arrive at the step where the science meets the human need for narrative. Not a dramatic narrative, a structured one. A timeline that explains what the evidence supports and what it does not. You start by turning marks into events. A drop pattern becomes a likely direction of travel. A transfer print becomes contact with a surface. A smear becomes movement across a stain. A cleaned area becomes an interruption, a sign that someone tried to edit the room. But you never forget that you are not inside anyone's head. You are not describing intent. You are describing physics and biology and the traces they leave behind. If someone asks you why, you can only answer how. This is the difference between reconstruction and storytelling. Reconstruction is constrained by material behavior. Storytelling is constrained only by imagination. One is a tool, the other is entertainment. So you lay out a calm sequence. First, the scene is found. Then, the documented stains and patterns. Then, the collection and lab results. Then, the interpretations that are supported, with the limits stated clearly. Then, the questions that remain unanswered. Those unanswered questions are not failures. They are the honest borders of the method. A good report has edges. It does not pretend to fill every gap. You might write that a pattern is consistent with impact spatter, for example, but you would also note that other mechanisms can produce small droplets. You might write that a stain tested positive in a presumptive test, then confirmatory testing supported blood, but you would also note potential interferences and the condition of the sample. You might write that a deoxyribonucleic acid profile matched a reference sample with a certain statistical weight, but you would also note that presence does not equal time. The language can sound cautious to the point of being tedious. That is the point. In this work, boredom is a safety feature. And when someone reads the report later, perhaps months or years later, they should be able to see what you saw, not through your feelings, but through your measurements. They should be able to follow your steps without guessing. They should be able to audit your work, which is a polite word for checking whether you messed up. Because you can mess up. any human can. And forensic science, when done well, is built to catch those mistakes before they become permanent. You see it in quality controls, in reagent blanks, in known standards, in peer review. You see it in confirmation testing and in replication. You see it in the insistence that you write down what you did, not what you meant to do. It is an entire culture designed around the fact that humans are unreliable narrators of their own actions. Even your memory is unreliable, especially your memory. So you lean on photographs, notes, and logs. You treat the case file like an external brain because your internal brain is soft and easily distracted. And if you are honest, that is quietly comforting. It means the work does not depend on you being brilliant. It depends on you being consistent. It depends on you being careful. It depends on you not trying to win an argument with the universe. Now, once the report exists, it enters a world where people will try to use it. Investigators will compare it to statements. Attorneys will look for strengths and weaknesses. A jury, if it goes that far, may hear simplified versions of what you wrote. And simplification is dangerous because it can sound like certainty. So an analyst often has to explain calmly what the words mean. Consistent with is not the same as proven by. Cannot exclude is not the same as did. Likely is not the same as certain. The world of science is built on probabilities, while the world of human judgment wants a yes or no. It is an awkward marriage, and like many awkward marriages, it survives through paperwork and patience. If you ever testify, you learn to speak slowly and answer exactly what was asked. You learn to correct misunderstandings without sounding defensive. You learn to say, "I do not know," when you do not know. And to let that be enough, because pretending to know is how science turns into performance. And performance is tempting. A courtroom is a stage. A camera is a stage. Even a conversation can become a stage when people want a satisfying story. But your job remains what it was in the taped room at night. Document reality, even when reality is unsatisfying. This is why the best forensic scientists sound a little dull. They are not trying to entertain you. They are trying to avoid making a confident mistake that cannot be undone. And with that mindset, you start noticing something almost tender. The world leaves patterns everywhere, not because it is meaningful, but because physics is consistent. A cup leaves a ring on a table. A hand leaves oils on a doorknob. A foot leaves dust disturbed on a floor. A drop leaves a circle, or an oval, or a constellation of tiny satellites. You do not need a crime scene to see it. You can look at your own life and find the same quiet traces. A worn spot on carpet where people always turn. A smudge on a light switch. A fingerprint on a phone screen that shows how you hold it. A scratch on a key, unique in a way you never intended. Forensics is just the formal study of what matter remembers briefly before time smooths it away. It is a discipline built around the fact that the universe is always recording and also always erasing. And that is why it feels so strange to call it solving. You are not solving an equation. You are assembling a plausible sequence from incomplete traces. You are building a careful narrative that stays attached to physical behavior. Sometimes that narrative helps someone understand what happened. Sometimes it helps exclude an innocent person. Sometimes it points to the right suspect. Sometimes it simply clarifies that the scene does not support a certain claim. And sometimes, despite all the careful work, it remains ambiguous. That is not because the science failed. It is because the world is not obligated to leave behind clean evidence. Still, you keep doing it because even partial truth is better than pure imagination. Even a modest conclusion is better than a confident fantasy. And in a system full of loud opinions, a quiet measurement is a rare kind of anchor. There is one more gentle irony here. The more you learn about evidence, the more you realize how often you are surrounded by it in everyday life. Not in a paranoid way, in a physical way. Every surface you touch becomes a little different. Every fabric you brush past collects a few fibers. Every step you take rearranges dust. You could treat the world as a constant crime scene if you wanted to ruin your own peace. But you do not need to do that tonight. You only need to understand that pattern making is normal. It is what matter does when it moves through matter. And now, as the paperwork settles and the case file takes on its final shape, there is a natural next thought, something quieter and older than any investigation. The night itself is a kind of laboratory. It is when rooms cool, when air stills, when surfaces collect what the day kicked up. The same physics that shapes stains also shapes fog on windows and dew on grass and the slow settling of dust in a sleeping house. Speaking of that settling, there is a whole other category of evidence that lives in the smallest movements and the smallest fragments, the kind that only becomes visible when you stop looking for drama and start looking for ordinary repeated behavior. That behavior is called transfer, and it is the closest thing the physical world has to gossip. You do not need a loud event for transfer to happen. You just need two surfaces close enough to touch and different enough to trade. A sleeve brushes a couch. A shoe sole meets a dusty threshold. A strand of hair drifts down and catches on a sweater like a tiny hook. Congratulations, you have participated in Locard's exchange principle, the fancy name for you cannot go anywhere without leaving crumbs of yourself behind. In plain human terms, Locard was an early forensic thinker who noticed something obvious. Every contact leaves a trace. Not every trace is useful, but it is always there in some form. The world is a constant, low-level swap meet of particles. So now you are down on your knees, not metaphorically actually down there. Your flashlight is low, almost parallel to the floor. At this angle, a smooth surface becomes a landscape. A tile seam casts a thin shadow. A stray fiber looks like a fallen tree. And dust becomes the main character. Dust is not one substance. It is a community of fragments that has agreed to share a name. Skin cells, shed in invisible snowfall. Textile fibers, broken off from clothes and carpets. Soil particles, ground small and tracked inside. Tiny bits of plant matter. Soot from candles, cooking, traffic, and whatever your neighbors are doing at midnight. In some places, even microscopic bits of insect and pollen, mixed in like seasoning. And because dust is made of so many things, it behaves in a very particular way. It settles, it drifts, it clings, and it builds thin layers over time. A shelf that has not been wiped becomes a slow diary. A windowsill collects a record of airflow. A floor corner becomes a museum of whatever the broom never reaches. On a crime scene floor, dust can do two useful things at once. It can highlight where someone walked, and it can highlight where they did not. A clean footprint on a dusty surface is not a print made by adding material. It is a print made by removing it. A negative image, like a photograph developed in reverse. You lean in and you see a faint outline. Not dramatic, not crisp, but a shape that repeats heel to toe. And you remember that shoes are engineered patterns, ridges and blocks and channels, all designed to fight slipping. Those channels collect dust, then stamp it elsewhere, or they scrape dust away, leaving a cleaner patch behind. This is why investigators love oblique lighting, the low-angle trick. It turns shallow texture into shadow. It turns the almost invisible into something your tired eyes can finally respect. Sometimes you do more than light. Sometimes you use enhancement powders applied with a soft brush. The powder clings to residues and oils, creating contrast. It is similar in spirit to fingerprint dusting, but used for larger impressions too. You do it gently because too much pressure turns evidence into modern art. Other times, you use electrostatic dust lifters. That sounds exciting, like a gadget that should beep. In reality, it is a quiet sheet and a quiet charge. The charge helps lift dust impressions onto a film, preserving them without smearing. You peel it up slowly, like removing tape from a wall. Careful, steady, boring. Boring is good. Boring means you did not ruin anything. And then there are the prints that are wet or sticky or three-dimensional. Mud, clay, soft soil at an entryway. Those are the ones you can cast, pouring dental stone into the impression. Dental stone is basically plaster's more disciplined cousin. It flows into detail and sets hard, preserving tiny ridges and nicks. You wait while it cures, because patience is part of the chemistry. While you wait, you start noticing something else about the floor. It is not just prints, it is pathways. Human movement tends to make repeating routes. People enter rooms in the same places. They turn the same corners. They pause near the same objects. Over time, that creates wear patterns, subtle dulling on a finish, faint scuffs, compressed carpet fibers. In a fresh scene, you can sometimes see a newer path cutting through an older layer. A recent disturbance in dust. A chair moved, leaving a cleaner rectangle beneath. A rug edge flipped slightly, revealing a lighter patch, protected from light and air. The world is constantly making these little before and after images. And there is a quieter kind of transfer that hides in plain sight. Trace evidence. Trace evidence is exactly what it sounds like. Small enough to ignore, common enough to be everywhere, meaningful only when it lands in the right context. A fiber on a jacket, glitter the herpes of craft supplies, traveling where it has no business. A paint chip with a particular layer structure, a tiny piece of glass that catches the flashlight beam and flashes once, then disappears. Glass is a surprisingly talkative material. When it breaks, it does not just shatter, it distributes. If a window breaks inward, most fragments tend to fall inside. If it breaks outward, many fragments tend to fall outside. Not always, because air pressure, wind, and the force direction can complicate it, but the general behavior is useful, especially when paired with other clues. Glass also carries class features and individual features. Class features are shared traits like thickness and tint. Individual features are unique fracture patterns like the jagged edges of a specific break. In rare cases, pieces can be physically fit together like a cruel jigsaw puzzle. That is called fracture matching, and it is one of the few times you can get very strong association from a material fragment. But most of the time, glass analysis is more modest. You measure refractive index, the way light bends through it. You check density. You compare elemental composition if needed. And you say, consistent with, because the world manufactures a lot of very similar glass. Paint can be similar. Paint is layers, primer, base coat, top coat, clear coat if it is automotive, or multiple house paint layers, one landlord cover-up at a time. Under a microscope, a paint chip looks like a tiny layer cake, except it tastes like regret. You can compare color and layer sequence. You can analyze binders and pigments. You can sometimes narrow down brand types or time ranges. But again, most conclusions are supportive rather than singular. All this small evidence has a shared problem. It is easy to lose. It is easy to contaminate. It is easy to move accidentally. So collection becomes almost ritualistic. You use forceps, cleaned and handled carefully. You use paper folds, called druggist folds, a neat way to trap small particles. You seal them inside envelopes. You label everything with the same disciplined handwriting, the same case number, the same calm format. You collect control samples because the environment has background noise. A carpet already has fibers. A couch already has food residues. So you need to know what is ordinary for that space and what is newly introduced. This is one of the more humbling lessons. A scene is not a sterile stage. It is a lived-in environment, thick with old traces. Your job is to find the traces that matter without imagining them into existence. And that brings you back to blood for a moment, because blood is not always alone. Sometimes a stain is a mixture, not just of people, bud plus cleaning fluid, blood plus dirt, blood plus laundry detergent, because someone thought a washing machine is a confession eraser. Those mixtures change how stains look and how tests behave. You learn to think like a material scientist, not just a detective. What is the substrate, meaning the surface? What is the matrix, meaning what else is mixed in? What is the environmental history, meaning heat, humidity, light, time? And what is the handling history, meaning how many humans have touched it since? The handling history is a quiet villain. Every touch adds potential DNA, not because people are malicious, but because people are shedding. You are a constant source of biological confetti. Even talking can add material. Tiny droplets leave your mouth when you speak. Most fall quickly, but in close work, they can land. This is why masks are used in many evidence collection contexts. Not for drama, for containment. And now, with all this tiny evidence in mind, you notice the corners again. Corners are where the world collects what it cannot keep suspended. Dust drifts until airflow slows, and then it settles. Hair rolls until it hits a baseboard. Fibers tumble like tiny dry leaves until friction wins. If you ever want to find old evidence, you check the quiet places, under furniture edges, along baseboards, in the folds of curtains, inside the seams of car seats, in the gap between a mattress and a bed frame, where coins and secrets go to hibernate. Cars, by the way, are their own strange ecosystems. A car interior collects fibers from every passenger. Sand from a beach trip 3 summers ago. Dog hair, if a dog has ever been allowed in, which it has. Food crumbs, because humans cannot sit still with snacks. And those crumbs feed insects, which add their own traces because the universe is committed to full-service complexity. So you document. You vacuum with specialized filters sometimes, capturing trace evidence into a collection device. You use tape lifts, pressing adhesive gently onto surfaces to pick up fibers and hairs. You do it in a controlled way, because tape can also lift paint or disturb a fragile smear. This is what people do not understand about forensic work. Most actions are irreversible. Every collection method changes the scene. You cannot unpeel tape and pretend nothing happened. You cannot swab a stain and return it to its original state. So you plan, you photograph, you measure, then you touch. And once you have collected the tiny stuff, you send it into the same quiet pipeline. Label, log, store, transport, receive, sign, analyze. In the lab, trace evidence work looks different than DNA work. There are microscopes, comparison microscopes, special lighting. There are solvents and refractive liquids for fiber comparison. There are instruments like Fourier transform infrared spectroscopy, which is a mouthful that means shining infrared light to get a chemical fingerprint. There is Raman spectroscopy sometimes, another light-based method. The lab becomes a place where materials confess through how they interact with photons. But no matter how fancy the instrument is, the tone stays modest. You can often say, these fibers are consistent in type and color. You can often say, this paint layer sequence is consistent. You can rarely say, this came from that one specific source unless you have a direct physical match. So again, boring language, careful truth. And now, because you are you start seeing the whole job as a strange form of listening, not to people, to matter. A smear says, something moved. A fiber says, something touched. A footprint says, something walked. A broken edge says, something forced. And blood, stubborn as ever, says something leaked and then tried to become solid. Time keeps working. Evidence is always moving toward lower information. Edges soften, colors fade, volatile chemicals evaporate. Microbes digest. Sunlight breaks bonds. Air oxidizes. Water dissolves and redistributes. The universe is a giant, patient shredder. Your job is to catch a few pages before they are confetti. And this is where you start noticing a type of evidence that is all about time. Not blood drying, but smell. Most people do not think of odor as evidence because it feels too subjective. But odor is chemistry. Volatile organic compounds, tiny molecules that evaporate easily and hit your receptors. Decomposition produces a specific cocktail of these compounds. Accelerants like gasoline have their own volatile signatures. Some labs can analyze these compounds with instruments, turning odor into measurable data. This is also why trained dogs can be used. A dog's nose is not magic. It is a chemical detection system with a brain attached. Dogs can detect very low concentrations of certain compounds. They can be trained for human remains detection, or for accelerants, or for other target odors. But dogs are also dogs. They have moods. They get distracted. They can be influenced by handlers if procedures are sloppy. So their use requires careful protocols, double-blind setups when possible, and documentation. Even then, a dog alert is usually an investigative lead, not a standalone conclusion. You see the pattern now. Almost everything is lead, support, consistent with. Because certainty is rare in messy rooms. Now, as you move through this landscape of tiny evidence, you start to appreciate why crime scenes feel strangely quiet. Not emotionally quiet. The work requires stillness. It requires you to move slowly enough that air currents from your body do not scatter dust. It requires you to pay attention to small changes in texture and sheen. It requires you to respect that every surface is both a canvas and a trap. And that slow pace reveals another kind of evidence, one that most people never consider: tool marks. A pry mark on a door frame, a scratch pattern near a latch, a gouge in soft wood. Tools leave signatures through their imperfections and through how they are used. A screwdriver tip is not perfectly smooth. A crowbar edge has microscopic nicks. When those edges scrape, they can leave striations, tiny parallel lines. In some contexts, analysts can compare tool marks to a specific tool using test impressions and comparison microscopy. This field, like others, has faced criticism about overstated certainty in the past. So modern practice emphasizes validation and cautious conclusion wording. Still, the basic physics is real. Hard material against softer material leaves a record of contact. And then there is the simplest evidence of all: damage. A torn fabric edge can show tension and direction. A broken latch can show force. A displaced object can show movement. A damage is tricky because life causes damage too. Doors stick, furniture scrapes, pets chew. Kids are basically entropy with shoes. So, you compare damage to context. Is it fresh or weathered? Is there matching debris nearby? Are there multiple indicators pointing the same way? You keep returning to that idea. One clue is a suggestion. Many clues agreeing is a pattern. Patterns are where cautious confidence lives. And eventually, after all the dust, fibers, hair, prints, glass, paint, and tool marks, you circle back to the beginning of the human process. Because all of this is collected so that later, someone can build a timeline that does not depend on memory. Human memory is soft. It changes when it is looked at. It fills gaps with what feels right. Matter does not do that. Matter just sits there, being itself, until time erases it. So the case file grows thicker. It becomes a quiet monument to process. Photographs that show context and detail, sketches with measurements, evidence logs with dates and signatures, lab reports with methods and limitations. And then, something almost funny happens. The most powerful part of the file is often the boring consistency. A stain documented the same way every time. A sample sealed the same way every time. A control included the same way every time. science as routine, not science as inspiration. This routine is what allows someone else, months later, to read your work like a map. They can see where you stood. They can see what you saw. They can see what you did and what you did not do. They can challenge it if needed, because transparency is part of honesty. And now you are drifting into the next phase, the one where time is no longer the enemy on the scene. It becomes the enemy in storage. Evidence storage is not glamorous either. It is shelves, lockers, refrigerators, freezers. It is temperature logs and access control. It is sealed packaging and periodic audits. Biological evidence often needs cool, dry conditions. Moisture is still the villain because it encourages microbial growth and chemical degradation. Heat speeds reactions. Light breaks molecules. So you store evidence like you are trying to keep it bored and asleep. Paper packaging is used for many biological items because it breathes. Plastic can trap moisture, creating a tiny humid chamber that grows mold. But plastic is sometimes used for dry items that need containment. Everything is a trade-off because the world is not designed for preservation. And even when you store perfectly, time keeps chewing. DNA slowly breaks down. Proteins degrade. Volatile compounds evaporate. Adhesives age. Even paper yellows because oxygen is nosy. So labs often prioritize what to test first. What is most likely to degrade? What is most probative, meaning most likely to matter? What is limited in quantity, meaning you only get one chance? This is another quiet pressure in forensic work. Not the dramatic pressure of an active chase, but the pressure of finite sample. If you use too much material on screening tests, you might not have enough for DNA. If you apply chemicals too aggressively at the scene, you might reduce later options. If you cut too large a piece of fabric, you might destroy pattern information. So decisions are made slowly and often with consultation. And here, in the space between science and procedure, you can feel the human side again. Not the emotional story, the organizational story. Forensic science exists inside systems. Police departments, laboratories, courts, budgets, backlogs, staffing, training, accreditation. Reality is not just physics, it is scheduling. Backlogs are common in many places. Evidence can wait in a queue, sometimes for months. Not because people do not care, but because careful work takes time and resources. Every sample requires controls, documentation, review. Every instrument needs maintenance and calibration. Every analyst has a finite number of hours and a finite amount of attention. So patience becomes part of justice, which is a strange sentence, but it is true. And because you are still in this slow, observational mood, you notice one more category of time-related evidence that is often misunderstood: bloodstain pattern interpretation itself. People imagine it as a tidy geometry problem. Angles, arcs, impact points, lines drawn back to a source. Sometimes it can look like that, especially in controlled conditions. But in real rooms, the world is messy. Droplets bounce, surfaces absorb, air currents deflect fine mist, clothing blocks some stains and creates others. A moving person is not a stationary sprinkler. This is why responsible analysts avoid overly specific reconstructions. They can often identify broad pattern types: passive drops, meaning gravity alone, transfer stains, meaning contact, projected stains, meaning force-propelled, and in some cases, patterns consistent with cast-off, meaning blood flung from a moving object. Cast-off is one of those terms that sounds like a dramatic gesture. In reality, it is a simple physics outcome. Blood on an object? The object swings. Droplets leave due to inertia. They fly off tangentially, like water leaving a spinning tire. Those droplets can create linear patterns, arcing distributions. But even here, you must be careful. Many motions can create similar arcs. Many objects can swing, and stains can be altered by subsequent movement, cleaning, or time. Then there is the category people love to argue about: high velocity impact, spatter. It is associated in popular culture with firearms. Small droplets, mist-like patterns, fine distribution. But droplet size depends on many factors, including force, distance, surface, and blood condition. And the term high velocity has been debated because it can encourage overconfident conclusions. So modern practice emphasizes measurable descriptions, droplet size ranges, distribution patterns, context with other evidence, and again, consistent with rather than proven by. If you are noticing a theme, good. It means you are thinking like a tired scientist, which is the correct bedtime mindset. Now, from this point, the case file is being assembled into what it will be: a calm narrative constrained by evidence. It is a timeline, but not a perfect one. A timeline with blank spaces. A timeline with uncertainty margins that no one wants to hear about, but everyone needs. You take the scene observations, you take the lab results, you take the trace analysis, you take the environmental notes, and you build statements like, the pattern distribution is consistent with movement from here to there. The presence of blood was confirmed on this surface. A deoxyribonucleic acid profile consistent with this individual was obtained from this swab. Fibers consistent with this textile type were recovered from this location. These statements are small bricks. No single brick is a whole house, but you stack them carefully and a structure appears. And then the most important part, you mark the limits. You say what cannot be concluded. You say what was not tested. You say what could have alternative explanations. You say when sample size was limited. You say when results were inconclusive. Inconclusive is not a failure word. It is an honesty word. Sometimes the most ethical thing you can do is leave the mystery partially intact, because when science pretends to be more certain than it is, people get hurt. Wrongful convictions are not a theoretical problem. They are what happens when overconfidence meets a system that wants simple answers. So modern forensic practice has been pushed, rightly, towards stronger scientific foundations. Validation studies, error rate estimation, standardized terminology, accreditation requirements, proficiency testing, where analysts must regularly prove they can perform accurately. It is not glamorous, but it is the backbone, and it is part of why forensic work can feel slow. You are not just doing science, you are doing science that must survive skepticism. Skepticism is healthy here. Skepticism is what keeps the work from becoming storytelling. And now, as you sit with that case file, you begin to sense the strange tenderness in it. Not tenderness in the events, tenderness in the method, Humans made a system to extract small truths from messy rooms. They made protocols to stop themselves from lying by accident. They made boring forms to keep evidence from turning into rumors. They made careful language to keep conclusions from growing into fantasies. It is imperfect, but it is an honest attempt at restraint. And in that restraint, you can find a kind of calm. Not because the world is safe, it is not, but because the world is consistent. Fluids spread, fibers transfer, dust settles, chemicals react, time erodes. Even when people are chaotic, physics is not. So you close one folder and you open another. Not a new case, just a different part of the same story. The part where these small, ordinary behaviors become a narrative that a human system can handle. You are not writing a thriller. You are writing a map, a diagram of a room with north marked and measurements, a list of evidence items with locations, photographs that show each item in place, then close up with scale, a description of methods, step by step, a summary of results with cautious interpretation, a section on limitations, because humility belongs in the file. And when someone later asks, "How do you know?" you do not answer with attitude. You answer with process. You can point to the photo. You can point to the chain of custody. You can point to the controls in the lab. You can point to the validation of the method. You can point to the statistical weight, phrased carefully. You can point to peer review, the second set of eyes that tried to catch your mistakes. You cannot point to certainty. You can point to support. Support is the real currency here. Now, as this continues, the case file will eventually leave your hands. It will become part of a larger investigation, or a legal proceeding, or an archive. And the room itself, that quiet, taped-off space, will return to normal life. This is always strange. A scene that felt like a universe becomes just a room again. Someone will sleep there. Someone will vacuum. Someone will spill coffee and swear at the stain remover. New dust will settle. New fibers will appear. Time will keep smoothing the sharp edges, because that is what time does. And you, with your tired, cynical scientist brain, can almost appreciate the indifference of it. Not because it is kind, but because it is predictable. The universe does not care about your case file, but it does care about evaporation rates. It cares about oxidation. It cares about friction and adhesion and gravity. Those are the rules that keep repeating long after any one story ends. And as you sit with that repetition, there is still more to notice, because even in the quiet